Hi. So I got up this morning and I thought, what a great day to actually think and talk about energy flow through an ecosystem. Well, not entirely true, but it is quite a great day to talk about it. So where do we start with energy flow through an ecosystem? Well, let's see. There, with that thing in the sky, the sun. Now, we're all used to seeing it, but we don't often think about the fact that all the energy on our planet actually derives from the sun. That everything that actually is an energy source that we use originally starts off as energy trapped in solar energy coming in through the atmosphere. And today we've got some really, really great sunshine, so I thought it'd be quite good. Okay, so first of all, I'm going to apologise about the fact that most of the day is actually going to be shot on a phone. So it's going to be a little bit jumpy in places. But one of the other things that I came out this morning for was the fact that we've actually got a mist in the valley that I live in. And as you can see behind me on those hills, there's actually a mist. And the mist is sort of starting to dissipate a little bit compared to what it was like earlier, maybe an hour ago. But as well as our food chains and food webs, the solar radiation coming in through the atmosphere is also driving a lot of our planetary systems. So weather systems are being driven by solar energy, and we've got a mist this morning because through night it was quite cold, and the cold air above the ground is now meeting a layer of air that's warming up from the solar radiation above, and water in the atmosphere is actually condensing out, creating this mist. So we've got another example of energy flow within ecosystems. We've got this energy, actually we can visibly see an energy barrier, an energy layer. Okay, so what's happening to that solar radiation? Well, this is what's happening to it. We've got the solar radiation actually being captured by plants, by green plants, by photosynthesizing organisms. And if we zoom in a little bit, we've got this entire layer of green chlorophyll-packed grass right in front of us that provides the initial step on the terrestrial food chain. Yeah, so obviously I'm in a valley and this is a terrestrial food chain, but the one thing that you notice that's really absent is herbivores. Yeah, the models that we've shown you, the models that you see in the textbooks, all have herbivores in them. So where are they? And normally in the valley here, there's cows, and I'm not really even thinking about cows that are grazing. They've been introduced by man, but they are herbivores. But where are the natural herbivores? And one of the disadvantages with textbooks is that they tend to show you one version. It tends to be the showy, the big version. So most of the versions that we have in textbooks tend to be based on places like the Serengeti or on big prairie systems. But there are herbivores here. What we've got to do is look for the evidence of those herbivores. Now this is going to seem like very, very strange evidence of herbivores, but I can't see a single herbivore, but there's plenty of evidence that there are herbivores about. The leaves on these bushes have all been eaten. Yeah, they've all been eaten by caterpillars of one variety or another, but there's evidence there that we definitely have herbivores in this system. Right now I can't find a single herbivore, but I can find plenty of evidence of the herbivores. So what that's sort of telling me is that, well, the numbers, the biomass of the herbivores must be less than the biomass of the plant species that they're feeding on. Yeah, and I've got lots of evidence. And why are they feeding on this? Well, I stopped here in particular because there's some wild grapes growing, and all of us like grapes, and they're packed full of sugar. So that sunlight in the process of photosynthesis is being converted into usable energy for other organisms. And they are being eaten by other organisms as well. Lots and lots of feedings happening here. There's loads and loads of evidence, but very, very, very few. Actually none. I can't find a single herbivore. So we can think in terms of the fact of the biomass. So what does this tell us about the herbivores? Well, the first thing is that most herbivory that happens on the planet is not great big grazing animals like giraffes and elephants. Most of the herbivory that happens is actually insects. And one of the things in terms of thinking about this in environmental systems is biomass. So I have plenty of evidence of photosynthesis happening. And I have some anecdotal evidence that there's definitely herbivores about. And if it's really hard to find herbivores, well, I definitely can't see any lions, tigers, bears, pumas. Can't even see any eagles flying overhead, and we get eagles in this valley. So the evidence of predators is even harder to find. Oh, or is it? If we come down in scale level and we're thinking about insects, well, maybe it's not as hard to find. And again, there's the sun, where the start of everything, and oh, look, we have evidence of predators, a spider's web. Yeah, spiders are sitting there, creating these webs, catching insects that are flying past. In this insect food chain, actually spiders are quite near the top of the food chain. Now here we've got another example, a beautiful example of a spider's web. So we've got an example then of predators in the system. So the spiders are here. They're obviously feeding on insects, or else they wouldn't be here, but their numbers, their evidence is actually lower. I've had to move quite a bit to find more evidence of a predator. Whereas I can find evidence of things being eaten on almost every tree. And another spider's web, an even bigger spider's web, sitting there in amongst bushes and grass, just waiting for unsuspecting herbivores, for insects to come along and actually become part of its energy source. So we've got quite a complex system in a very, very small distance, at a much smaller level than maybe the textbooks are showing us. So this valley contains multiple habitats. It contains grassland habitats, it contains transition zones between grasslands and forest habitats. And in all of that, we can definitely see the photosynthesizing area. But it's much, much harder to see the food chains and the trophic levels above that. But it's definitely happening. There's evidence there if you look for it. So let's have a look at this idea of what actually is a food web, or a food chain in this case. So this is the sort of image you're used to seeing in the textbooks. Cotton grass, lemon to wolf. This is what's happening in an Arctic ecosystem. However, in this ecosystem, what we've actually got happening is, again, grasses. The particular grass that I'm thinking of this time is a grass called bromus, and they're being eaten by grasshoppers, and every now and again grasshoppers end up landing in a web and a spider's eating them. Yeah. In the particular case here, the spiders tend to mainly be something called a wasp spider. So we've got a local example of a food chain, and we've got the three levels in there. We've got the trophic level 1, trophic level 2 and trophic level 3. But is everything eaten? Well no. You can see here these are actually blackberries. They grow on the bramble bush, and whilst they get fed on a lot by insects, by grazing animals, by birds, these ones have actually started to rot. They're starting to break down. They've not been eaten by anything. So we get this loss of matter along the food chain. Not all matter in each compartment of a food chain is eaten by the next compartment of the food chain, and this creates the detritus food system, or the decomposing food system. And we can see decomposition starting to work here as they're dying off, and actually starting, well, the blackberries are starting to be infected by yeast. Yeast are starting to break them down again. And maybe not a natural example of this, but it's still a very, very good example. What you're looking at right now is cow dung, and that's really an example of the second law of thermodynamics. Yeah, that we've got wastage within the system, that the cows have eaten the grass, but not all the grass has been converted into useful energy by the cows, so some of it has passed through, and there's still biomass inside there, which will obviously enter the detritus food chain. And I finally managed to find a herbivore. So there's a slug here, moving its way very slowly through the grass. It's gone along, you can see them actually on the edge of a roadside at the moment. But it's going into the habitat that I've actually just been looking at, and it's slowly chomping its way through plant material. So in trophic levels, this is actually the second trophic level. It's a herbivore, and I think they're rather elegant and beautiful. I know lots of people will go, ugh, but I think they're absolutely amazing. And there we go, I finally managed to find a spider actually sitting in the middle of its web, and my camera was going to be too shaky for you to see it, but the spider's actually sat there with an insect captured and wrapped up in silk, and the spider's slowly digesting that insect with enzymes. It's slowly feeding away. So yeah, we actually have an example there of another tertiary level of another trophic level, a tertiary trophic level. Yeah, so we've got plants, we've got herbivores, and we've got predators preying on the herbivores. So yeah, I'm quite pleased now. And so back where I started on this little 15-minute safari, to be honest, I've had a little stroll around the village, around the area that I live in, and very, very quickly I found evidence of the first law of thermodynamics, that we have solar radiation entering the system. It's being absorbed by plants, and through photosynthesis we're having a laydown of biomass that's then used by herbivores as their source of energy, and the herbivores are providing a source of energy for carnivores. So we've got 3 trophic levels very, very quickly. Yeah, within a very small area. And I guess that if you go and have a wander around your locale, no matter where you are, even if you live inside a city, you're likely to be able to find a very, very simple food chain that actually is much more interesting than talking about giraffes and lions on the Serengeti. Much, much more interesting because you can actually personalise it. It's something that you can find out about, that you can know about. And then we've also had a couple of illustrations of the second law of thermodynamics, the fact that energy spreads out in the system, that we have this increase in entropy, increase in disorder. So not all of the energy trapped in one level of the ecosystem is actually being used in other levels of the ecosystem. So we've got blackberries still on a bush that are starting to rot. They're not going to be used as an energy source. The energy that's been absorbed will actually be lost from the system. Well, actually it won't be lost from the system. It will now enter the detritus food chain. And we tend to forget about that. And whilst not a natural example, the cow dung, very, very important for fertility of the soil, putting carbon and nitrogen back into systems. So very quickly, within about 20 minutes, managed to do quite a lot of topic 2.2 just on a little walk. So why don't you try your own little walk in your own ecosystem? Okay, hopefully this has been a little bit more useful than reading the dry material in a textbook, and maybe it'll help to understand the idea of energy flow a little bit more within the ecosystem.